Welcome everyone to Mr. Schultz's Integrated Math 2 class as we delve into our second part of 4.5 Trigonometry. Welcome to part 2. So example 5, using trigonometric ratios to find side lengths. This is your warning, you need a calculator. Solve for the missing side lengths. First, we're going to see which trig ratio we should use. Remember, SO, CA, TOA. So, CA, TOA. That means we want the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is equal to the opposite over the adjacent. So what we are going to do is we are going to use a calculator to figure out what are our side lengths. Looking at this, it looks like we have to figure out which trig ratio we should use for the first one. We have our hypotenuse, even though it looks like adjacent. This is the hypotenuse because it's across from the 90 degrees. And we have the opposite. So opposite over hypotenuse is our ratio. Well, which is that? The sine. So we are going to take our calculator and we're going to figure out the sine of 25 is equal to x over 12. Well, how do we do that? Well, grab your handy dandy calculator and let's continue. So looking at our calculator, this is the same calculator I used growing up. We're going to see that, hey, first we have to make sure that we are in the correct mode. Turn it on, go to mode, and make sure it's in degrees because radians is something a little different. It's a different unit of measurement. Make sure yours is in degrees. Now, go back. Now we want the sine of 25. So plug it in. And we get 0.423. So I'm going to put 0.423 is equal to x divided by 12. Now we don't want to solve for x divided by 12. We want to solve for x. So what is happening to x when we have x divided by 12? It's dividing. So what's the opposite of dividing? Multiplying. So in our calculator, all we have to do is times this result by 12. Now you might be thinking, how am I going to take this whole decimal and multiply by 12? Well, if you already have it right here, sometimes you just have to push times 12, and it will give you the answer. There you go. So x is equal to 5.07. All right, go ahead and let's try the next one. First, I want you to figure out which trig function ratio should we be using. Guessing in 3, 2, 1. Well, it looks like we have the adjacent and we have the hypotenuse. The trig function that is the adjacent and the hypotenuse is cosine. So you have to figure out the cosine of 40. And we understand that's equal to x over 16. So at this moment, I'm not a calculator, but you should have one. I'm going to write the answer right here in 3, 2, 1. So there's two things when we're doing this. The answer is going to be 12.26 is equal to x, but I want you to make sure that you have the work. Find the cosine of 40 and then multiply by 16. Now there is a problem sometimes. Let me show you my work in 3, 2, 1. If you do not close certain parentheses, it's going to give you a different answer. So for example, I found the cosine of 40 and then I multiply by 16. If I find the cosine of 40 and I forget to close it with the other parentheses and I times it by 16, what I'm pretty much telling it to do is I'm saying, hey, I want you to find the cosine of 40 times 16, which is completely different than find the cosine of 40 and then times 16. As you can tell right here, 12 is not the same thing as 7.17. All right, let's go on. All right, so let's do the next one together. It looks like I have the opposite and I have the adjacent. So that's going to be my tangent. Now I have to figure out TOA. So it's OA. It's going to be the tangent of 70 is equal to the opposite over 10. Well, pretty much all I'm going to do is I'm going to click tangent of 70. Figure that out. 2.7475. 2.7475 is equal to y divided by 10. And then multiply by 10. I don't need to use a calculator on this. I just multiply by 10, and I know that the answer should be 27.4, and I'll round this up. 8 is equal to y. Maybe I want to box my answer. Maybe I don't. I don't know. Now let's give the next one. Once again, I want you to figure out what we should use. In 3, 2, 1. Well, looking at this, we have the adjacent and the hypotenuse. So, cosine. So, in your calculator, I want you to do the cosine of 58 is equal to x over 11. Go ahead and figure that out in 3, 2, 1. So, x in this situation is 5.83. All right, guys, let's go on. But wait, pop quiz. For some extra credit, your group will need to figure out what is x, y in this situation. And do it however you want. You can use cosine, tangent, sine. Any of these will work for you. Hopefully you figure out which ones should work and which ones shouldn't work. So, if I'm in class right now, go ahead and figure this out. And we're going to go on in 3, 2, 1. All right, guys. Let's go on to the last one, and let's see if we can get this under 10 minutes. We are at 8 minutes and 20 seconds now. So, let's do the right one right here. Solve when the variable is in the denominator. Once again, I understand that I'm going to figure out this is the hypotenuse, and we have adjacent. I look at it, I know hypotenuse and adjacent is the cosine. So I'm going to say the cosine of 41 is equal to the adjacent 19 over the hypotenuse. All right, well, at this moment, I'm going to tell you, hey, we could figure out this, but I'm going to move these x out of the denominator. After I do that, I'm going to have x times cosine of 41. Now, I'm not going to touch it. I'm going to say, hey, this is the cosine of 41 is equal to 19. Then, what's the opposite of times cosine of 41? Divide by the cosine of 41. So what's 4 divided by 4? 1. 3 divided by 3? 1. Cosine of 41 divided by the cosine of 41? 1. But 19 divided by the cosine of 41, because we are doing the division property of equality, well, get out my calculator. I don't want to do the work. So let's bring it over here, and we say, hey, clear this data. I want 19 divided by the cosine of 41. Now, technically, maybe we should, solve the problem. Does this make sense? Well, 25.18. Yeah, 25.18 is equal to x. It's not too far away from the adjacent right here. 25.18 does make sense right here. Now, if I had found the cosine of 41, I could have figured out by dividing 19 what the answer is. All right, let's stop for a second. Oh, we broke 10 minutes, but let's see if we can do the last one in lickety-split. All right, so we're trying to figure out this with the hypotenuse and the opposite. That's sine. So we're going to find the sine of 64 is equal to 15 over x. Well, once again, I just times it by x on both sides. And then what I want to do is I want to divide by the sine of 64 on both sides. Well, I don't want to jump in and just do it. Let's figure out. I want to divide 15 by the sine of 64. But what is the sine of 64? So now I'm going to do 15 divided by that. So I go 15 divided by 0.89888. Round up a little bit, but go far enough so that it doesn't affect the answer. So I get 16.69. So 16.69 is equal to x. Well, let's go back and make sure I get 0.8988. 0.8988 is equal to x. Alright guys, so the rest of these you are going to solve. We have these two right here, I'll help you with them. And then after that, you are going to work with your group, your partner, or by yourself to answer the next 2 pages. Now there are 16 problems, so I need you to try your best to work together to find the solutions. Alright guys, this is the end of part 2, and I will see you in class.